Hey, let's take a look at some inequalities involving two triangles. So here's the first one. What I'd like us to do is I'd like us to compare this angle, angle ACB, right there, to angle BCD, right here. So I want to compare these two angles. Well, how can I do that? Well, I have two different triangles, and I know the measures of some of the sides. In fact, you can see that since the length of AC is the same as the length of CD, that these sides are congruent. But notice that this has length 5 and this has length 6. These are not congruent. However, they share a side. Don't forget about poor BC. And so look what I have. I have two triangles where I have two pair of sides that are congruent. And therefore, I know by the converse of the hinge theorem that, in fact, if the opposite sides to these angles are non-congruent, then the larger side will be opposite the larger angle. And so what that tells me is that this angle has to actually be larger than this angle. And that's by the converse of the hinge theorem. So again, we see that we have side congruent to side congruent to side in two triangles. And then if the third sides are not congruent, the larger side of one triangle is opposite the angle that's larger to the comparative side angle of the other triangle. So there you have it. Let's try another one together so you can see this happening in real life. So here again we see two triangles. I notice that this has a side length of 10 and this has a side length of 10. They also share the side SQ. And so this is congruent and these sides are congruent. And I want us to compare this side length to this side length. And what do I know? Well, here I see that the angle in between these two sides, in one case is 45, and in the other case, the corresponding angle is 40. So by the hinge theorem, since this angle is larger than this angle, this side must be larger than this side. And so this side must be larger than that side. Neat! We actually can say something about the sizes, the relative sizes of different parts of triangles via the hinge theorem or its converse. Very cool. Here's one that has a little bit more of an algebraic feel to it, so let's take a look at this one. So here I've got two triangles that are put together. Notice that I'm told that this side is congruent to this side, so they have the same length. They also share this side. Remember, if they share the side, that means that they have another pair of sides that are congruent. And now what I'd like to do is I'd like to give an upper and lower bound for the possible angle measures of this angle right here, LNM, the angle right in here. I'm writing it as 2z minus 6 in terms of its measure. So the measure is 2z minus 6, and I want to know what's the smallest and what's the largest that angle can be. Well, there's a couple things that we can do here that are sort of silly. The silly thing is that we know that that angle has to be positive because it's the angle of a triangle, and so it has to be greater than 0. So I know that we have 0 is less than 2z minus 6. I can solve that inequality by adding 6 to both sides. I see 6 is less than 2z. If I divide both sides by 2, I see that 3 is less than z. And so I see immediately that what I can say here is that z has to be greater than 3 degrees. Now, is there an upper bound for z? Well, let's take a look and look at this thing a little bit closer. I've got this side congruent to this side. I've got this side congruent to itself. And I see that the opposite side to this 90-degree angle, this right angle, is 17, whereas the opposite side to this mysterious angle, 2z minus 6, is actually going to be 16. So by the converse of the hinge theorem, since this side length is shorter than the corresponding side length here, then we know that this angle has to be smaller than this angle. This angle we see is 90 degrees, so this angle has to be less than 90 degrees. And so I see that this has to be between 0 and 90 degrees. And so now I can give an upper bound for z. If I give an upper bound for z, what I'd see is that 2z minus 6 has to be less than 90. If I add 6 to both sides, I see that 2z has to be less than 96. Dividing both sides by 2, I see that z has to be less than 48. And so therefore, I have a range for z. It's between 3 degrees and 48 degrees. I'm not allowed to equal either of those, but anything in between 3 and 48 is fair game for z in order to make this picture actually make sense and be correct. The hinge theorem.